All right, question 54, we're back to differential equations here. In this specific problem, we have a first order differential equation because of this y prime here. And it turns out there's this method called the integrating factor method that solves first order differential equations of the form y prime plus some function, maybe I'll call it p of t, times y is equal to some other function, maybe I'll call it g of t. So in this specific problem, playing the role of p of t is this 2t, and playing the role of g of t is e to the negative t squared times sine of t. What the integrating factor method does is actually fairly simple. You just find this thing called the integrating factor, and you multiply both sides of the equation by that thing, and that creates a product rule that you can get rid of by integrating. So maybe first just the method, and later I can go back and justify the steps. The first thing you want to do is find the integrating factor. That's typically denoted mu of t, and it's always just equal to e raised up to the antiderivative of p of t. So in this case, since p of t is equal to 2t, the antiderivative of p of t is just the antiderivative of 2t, which is just t squared. And since the integrating factor is just e raised up to the antiderivative of p of t, the integrating factor in this problem is just e raised up to the t squared power. So far, so good. For step 2, all we have to do is multiply both sides of the equation by that integrating factor. So we take our original differential equation here, and we multiply both sides by e to the t squared power. It might look like you're just making things kind of ugly, but a little bit of calculus magic just happened. This thing on the left-hand side is just the product rule, right? Maybe you remember the product rule is telling you that the derivative of f times g is f prime g plus g prime f. Playing the role of f here is the letter y, and playing the role of g is our integrating factor, e raised up to the t squared power. If f is y, f prime is just y prime. If g is e to the t squared power, thanks to the chain rule, g prime is e to the t squared power times the derivative of t squared, in other words, 2t. f prime g plus g prime f. Because we've managed to create this product rule over here, step 3, where we integrate both sides, is really easy. Since the derivative of fg is f prime g plus g prime f, the antiderivative of f prime g plus g prime f is just fg. What I'm saying is the antiderivative of all this stuff in the box is just y times e to the t squared power. On the right side of the equation, we got the antiderivative of e raised up to the negative t squared times sine of t times e raised up to the positive t squared. This simplifies very nicely. E to the negative t squared times e to the positive t squared is just equal to 1, because think about when you multiply together exponential expressions that have the same base, you add their exponents, and negative t squared plus positive t squared is 0, and e to the 0 is equal to 1. So on the right side here, all I'm left with is sine of t dt. The antiderivative of sine of t dt is easy to figure out. Let's see, the derivative of cosine is negative sine, so the antiderivative of sine is negative cosine. If I divide both sides of the equation by e raised up to the t squared power, I get that y is equal to the negative of the cosine of t plus my arbitrary constant c divided by e raised up to the t squared power. I'm told in this problem that y of 0 is equal to 0, so I can solve for that arbitrary constant. All I gotta do is change all the y's into this 0 and all the t's into this 0. So I get 0 is equal to the negative of the cosine of 0 plus this constant c divided by e raised up to the 0 squared power. 0 squared is just 0. E to the 0 is equal to 1. So I get 0 is equal to the negative of the cosine of 0 plus c. Cosine of 0 is equal to 1. So I get that 0 is equal to negative 1 plus c, and c is equal to 1. Now that I know what my arbitrary constant is, I can rewrite my solution over here as negative cosine of t plus this constant 1 divided by e raised up to the t squared power. What the question asks me, for some strange reason, is what y of pi is equal to. All right, all I got to do now is change all the t's into pi's. Y of pi would be equal to negative cosine of pi plus 1 divided by e to the pi squared power. Let's see, cosine of pi is negative 1. The negative of negative 1 is positive 1. 1 plus 1 is 2. So I get 2 divided by e to the pi squared power. But if I remember right, we want to write the answers without these fractions. So what I'm going to do is take this e to the pi squared power and throw it up on the top of the equation. By negating the exponent, I get 2e to the negative pi squared power. 2e to the negative pi squared power is answer E. So E is the answer to this question. As long as you know this integrating factor method, it's a pretty straightforward process. I guess the challenge is making sure that you know all the required differential equations methods. Maybe when I finish this test, I'll go through and make a video on that.